Hi, welcome to the Shuko Math Lab. It is the time to solve some differential equation again. All right, so during today's problem-solving session, here is the differential equation we are going to solve is x squared y prime minus cosine 2y equal to 1. The initial condition is y2 equal to negative pi over 4. Okay, so let's take a look at this problem here. So this problem, we have this cosine 2y's here. So we know this is not linear. And but there's one, if you look at again, so the good observation is they have all the y in a term and all the x in a term. Why I said this is a very good observation because then this will be a good candidate for what for the separation variable separations here. So let's take a look here. All right, so let's rewrite it. So this is x squared dy dx. Okay, then for the cosine 2y, typical, I like to simplify that as for the, let me put here cosine 2y equal to 1. And then, typical, I always like to get the double angle and simplify it to the single angle. The reason why, for integration point is, so sometimes you'll be able to apply the different identities. It's easier. All right, so let's take a look at the double angle formula for cosine. We know the cosine 2 theta is equal to the 2 cosine square theta minus 1, right? Okay, so for these ones here, so this is minus cosine 2y. So will be 2 cosine square y minus 1 equal to 1. And then I can, this is x squared dy dx minus 2 cosine square y and the plus 1 equal to 1. Okay, so this 1 and 1 I can cancel. So I will have here x squared dy dx and the minus 2 cosine y equal to 0, right? So it's a minus 2 cosine square y equal to 0. Then I can move this term dy dx equal to the 2 cosine square y. Now you can see what I mean when they're all by themselves, right? So for here, so for example, this is a cosine, is all y, this is x. So this will be an excellent candidate for the variable separation. All right, so I put all the x in one side, y to the other side here. Okay, so I moved, so this is dy. Then I can move the 2 cosine y over here. Okay, so I will put the cosine square y, and then I can move the dx there. So this is dx, and the x squared, I still have a 2 in the front. You see here, so now I can integrate both sides here. So this one's here, this is dy, and this is cosine square y. Now I can integrate it to the dx x squared. So this one's here is the second square y dy. And then for this integration will be x to the negative 2, right? So it will be negative 2 plus 1, x to the negative 2. So the right-hand side will be negative 2 to the x here. Okay, right? So here, then the plus c. Then we know the second, well, that is another very good identity. I know the second square you integrate will be what? It will be tangent y equal to negative 2, the x plus c. Okay, So now my initial condition is y2 equal to the negative pi over 4. So in here, I will have tangent y equal to the negative pi over 4 is equal to the negative 2 over 2 plus c. So here, negative pi over 4, it will be negative 1 is equal to the negative 1 plus c. So good. So c equal to 0. Now I can substitute the c back to my equation here. All right, so back to my equation here. Okay, so now my final answer will be tangent y will be equal to negative 2 over x, or now you can say y equal to the arctan negative 2 over x. So it turns out that this one is a very simple differential equation, if this is a nonlinear. But after spot, all the y in one function, x in one function, the first thing that I will try is to see the variable separations here. All right, so this is an easy problem, and I hope that this can help you for your homework. All right, so that's it, and talk to you next time. Okay, have a good day. Bye.